So when we're solving the equation from before, right, here, right, we did all the operations, and basically we just worked with the coefficients of these. And the variables, the x, the y, and the z, nothing really, they didn't really contribute to anything. They just were there for the ride, right? Like they just came along for the ride, yeah? Which tells you they're really like irrelevant, you know what I mean? So, which also tells us, so we don't really need the variables. All we need is the coefficients to do this. Well, that's where matrices come in. You can use matrices to solve equations like that, okay? And it allows you to only work with the coefficients without having like the extra fluff of the variables. So what you have to do is you have to convert the system of equations into what we call an augmented matrix, okay? Okay, the augmented matrix looks like this. So basically, look here. On the left side, you put in all of the coefficients from the equations, 5, -5, -5, and so on. We have a dotted or a solid line. It doesn't matter. There's a vertical line. And then you have the constants, right? These constants in the last column. That entire thing is the augmented matrix. Sometimes all you need is the matrix from the left, right? Just the coefficients. That's called the coefficient matrix. Now, you can do the exact same operations as you did for this previous one, but with these, okay? And it will turn out the exact same thing. And all of the operations are exactly the same. And when you finish, you end in row echelon form, which means this is what the matrix looks like. You have in row echelon form a main diagonal of all ones. Everything underneath is zeros. And then the numbers just happen to be above here in that triangle. All right? Now, sometimes you end up with a row full of zeros. That happens. And when that happens, we normally write it as the last row at the very bottom in order to preserve like row echelon status. Okay? Yep.
So could you like move a row down?
You are always allowed to interchange rows. That's free.
So like for B, in the second one, all of them.
You can, yep, you can flip-flop, yep. Okay? So speaking of here, A, B, and C, we want to see whether the matrices as they stand now are in row echelon form. So the first one, main diagonal, underneath everything is 0. So yes, it's in row echelon form. Here, look at this. This is not in row echelon form, right? Because you don't have a main diagonal of 1s. No. Now, as Scotty pointed out, you can rearrange the rows here, right? And put it in row echelon form. Then it'll be a yes, but right now it's a no. Okay? This one here, main diagonal of 1s, 0 in the triangle underneath. That's fine. This works. And then you have a full, row of zeros, correctly placed at the very bottom. This is in row echelon form. Yep.
What's like the point of those zeros at the bottom?
They actually do. They'll tell you whether you have infinite solutions or no solution or that. So if you have a full row of zeros, that's 0. That's 0 equals 0, which is infinite solutions. Yeah. Okay. Now, tips and tricks. We're going to do the same thing as we did before. We're going to start with entry A31, so bottom left corner, then the one right above, then the one to the right. So same order as before. Okay, let's do this. So right now it says to solve it using an augmented matrix. All right, and we're going to, okay, Now, the term Gaussian elimination, that's the process of what you're doing. You can do Gaussian, you can apply Gaussian elimination to the equations like we did yesterday, or you can apply it to the matrix. So that doesn't have anything to do with is it a matrix or is it an equation. That's just the process, okay? So we're going to do Gaussian elimination on this matrix right here. Okay, so let's first write down the matrix. So it's going to be 5 minus 5 minus 5, 35. Oh, you know what? Before I do that, sorry, do you see how you can divide that whole thing by 5s? Yeah. Why don't we go ahead and do that? So now I have 1 minus 1 minus 1, 7, negative 1, 2, negative 3, negative 12, 3, negative 2, 7, 30. Okay, and I put that vertical line. I don't do a dashed line because I feel it takes too long. Same as before, I have row 1, row 2, row 3. Okay. I'm first going to eliminate this one. That means the other two will copy over. Okay, now, so just look at this column, right? What can I do to get a 0? What operations can I do with the 3 and one of the other ones to make this a 0? What do you think? Multiply this by 3, you get a negative 3. Add it to this, you get a 0. Okay? You ignore all the other columns. You just look at what can I combine the 3 with and how to get a 0. Okay? So we're going to do, what were we going to do? 3, row 2 plus row 3. That's 0. Okay, and then all the other ones are going to be the same, right? So 6 minus 2 is 4. Negative 9 plus 7 is negative 2. Negative 36 plus 30 is negative 6. Okay, next I'm going to get rid of the one above, right? That negative 1. This is what I'm going to get rid of next. Okay, now, so I go over here. Okay, do you know? Okay, so I'm going to copy this one. 1, negative 1, negative 1, 7. I'm going to copy down the last row. But do you see how you can divide that whole thing by 2? Yeah? Like you can, let's do that. You can do more than one operation at a time, you know, like in each step. So I'm going to just do half of row 3. So that's going to be 0, 2, negative 1, negative 3. Okay, now, how to get rid of that minus 1? How to make the negative 1 0? What am I going to do? So just look in this column. Okay? I mean, there's really only one thing to do. Huh? Add them. Add. So do you see how if you add these two, you get a 0? Yeah. So you're going to do row 2 plus row 1. So 0, 1, negative 4, negative 5. Okay? So what does that get me? Now I'm in good shape. What's the next one I need to get rid of? This 2 over here. So I say, all right, so let me copy over the other ones. 1, negative 1, negative 1, 7. 0, 1, negative 4, negative 5. Okay, so, okay, when you get to this step, you can really only combine it with the one right above it because you have 2 zeros here, right? So I'm going to do 2 row 2 minus row 3. 2 times this minus this. 2 row 2 minus row 3. So to get rid of this one. Okay, so 0, 0. Okay, 2 row 2, that's negative 8, minus that one is negative 7. 2 row 2, negative 10, minus that one is also negative 7. Oh, look at that. Okay, next.
Wait, isn't negative 1 should be negative 9?
Huh?
Isn't it negative 4? Wait, because 2 times negative 4 is negative 9.
Minus negative 1.
Oh.
Yeah. Yeah, that's what gets you. So we're almost at row echelon form. To put it in row echelon form, I need that main diagonal to be 1s. So 0, 1, negative 4, negative 5. So what am I going to do here? Row 3 divided by negative 7, 0, 0, 1, 1. Now this is in row echelon form. Okay? So, okay. So basically this is when you stop, when that's equal to 1. Okay? When this one is equal to 1 right here. Okay. Now, let's talk about what all this means. Okay? Right. This first column represents the x column. The next one, the y, and the next one, the z. So the way in which you read these is this. First row, okay? First row, 1x minus 1y minus 1z equals 7. Second row, 0x plus 1y minus 4z equals negative 5. Third row, 1z equals 1. So that's what we're going to take. From row 3, we have z is equal to 1. Huh?
Oh, it's not over.
Yeah.
Did after.
Okay, now, from row 2, we have that y minus 4z is equal to negative 5. Y minus 4 times 1 is negative 5. So y is negative 1. From row 1, I have that x minus y minus z is equal to 7. X plus 1 minus 1 is equal to 7. X is 7. So I get 7, negative 1, 1. That is my solution. Okay? So much cleaner, right? Than having like the XYZs come along. Now, even at my age, okay, having done these for most of my life now, and that's truth. I've known how to do these longer than I've not known how to do them. Does that make sense? Yeah. To this day, when I'm solving matrices or when I'm solving systems of equations like this, whether it's matrices or not, I put aside all of the distractions, right? So I'm not talking to my friends downstairs, right, while I'm doing it. I'm not watching, math videos while I'm doing it, right? Everything gets turned off. It's just got to be you and this, because, man, one negative mistake and you're done. Then you have like 1,347 equals, like 3,251, and you're like, what is this? Then you go back and you're like, oh yeah, that was supposed to be a 2, not a 1. Okay? And then it just fixes it all. So you just have to focus. And it's very easy to get frustrated. It is, because you just want to like, In that case, when that happens, here's what you do. You try it once, you try it again, it's still not working, and now you're getting flustered, and like tears are coming out. Here's what you do.
Yeah.
Here's what you do. Close it, step away from it for 5 to 10 minutes. When you come back, you do another problem. Then when you're in a calmer state of mind, you go back to it, because what happens is it becomes memory. And so even when you do it 3 times over, you end up making the same mistakes again, because it's just like etched in your brain now. Yeah? Ever happened? Yeah? Ever had that happen to you? That's normal. Okay, it happens to the best of us. So this is what we do. Okay, Special cases. Okay. When you can't write a matrix in reduced row echelon form like this, it either has no solution or it has infinitely many solutions. So, which one do you think this will be? Okay, so here, I've thrown another term at you here, Gauss-Jordan elimination. Don't worry about it. Don't worry about it. We're just going to do Gaussian elimination, okay? All right, so we're just going to do Gaussian. I'll tell you later what Gauss-Jordan is. I'm not like keeping it a secret or anything. Okay, so here we go. Let's turn this into a matrix. 1, 2, 1, 8. 2, 3, negative 1, 13. 1, 1, negative 2, 5. Okay? Okay. Now, first, I'm going to get rid of this one. Okay, I'm going to show you all something. Okay? You can combine more than one thing in one step. It eliminates the writing. So, here's what we're going to do. We're going to change that one, right? How are we going to change that one? How are we going to make that into a 0? What do you think? What should we do?
Row 2 minus
2 row 2 minus
2 row 3.
There's
row 2 minus 2 row.
Let's use row 1 and row 3. Because we can do that. What do you do? Row 1 minus row 3. It's so much cleaner. You can do the other one too. It's not wrong, but it's cleaner, right? So, row 1 minus row 3. So 1 minus 1 is 0. 2 minus 1 is 1. 1 plus 2 is 3. 8 minus 5 is 3. Okay, the next one I had to get rid of was this one, right? Yes? I'm going to do it in the same step. Okay?
Is the order, so it's the left bottom corner, then the one above, then the
Yeah.
one to the right bottom corner? Okay.
Okay, now look. I used row 1 and row 3. Now I need to use like row 2 and another one. I can use row 1 again because I'm using it with row 2 this time, okay? So let's do 1 and 2 this time. So 2 times 1 minus 2, right? 2 row 1 minus row 2. Does that work?
Yeah.
2 row 1 minus row 2. Okay. 0. Okay. 4 minus 3, 1. 2 minus negative 1, 3. 16 minus 13, 3. And then the next one, we're just going to copy it over. Okay. Now, what do you notice? What do you have?
Row 2 and 3.
Row 2 and 3 are the same. So here you have 2 identical rows. So what happens now, right? This means there's an infinitely many solutions. You can't say all real numbers. It's just infinitely many solutions. Because what happens if you now wanted to get rid of this one, right? What would you get? Let's say you wanted to get rid of this one. I don't necessarily want to make you write this, but I'll just do it. You just watch. So we would have gotten 1, 2, 1, 8, 0, 1. Yep. If I wanted to get rid of this one, I would subtract row 2 minus row 3 and get 0, 0, 0, 0, which means, you know, I would get 0 equals 0, which is all real numbers. Okay? So, it's infinitely many solutions. Okay, so here is what we do when we get this.
You only have infinitely many if you have 2 identical rows.
Yeah.
That's the only
Because only when you get 0, 0, 0, 0 at the bottom will you get that.
What about the one on top? Like
The one on top is irrelevant because look at what happens
What
now.
if you can get 0 through like row 3 minus row 1? Or like, you know, like the top one and the bottom. If any.
Oh, it doesn't matter. Yeah, if you have 2 identical rows anywhere.
Okay.
Yeah. Okay, so now here's what you do. You solve one of the equations for y. So what do you have here? We have y plus 3z is equal to 3, right? y is 3 minus 3z. Why do we solve it for y? The answer is because we don't want to solve it for z. You solve it for anything but z, okay?
Yeah.
I know. Next, okay, go to row 1 and solve for x. Never z. So, what do we have in row 1? X plus 2y plus z equals 8. X equals, actually, you know what? Here's what I'm going to do. X plus 2, what's y?
3 minus 3z.
Yep. Plus z is equal to 8. So here we have x plus 6 minus 6z plus z is equal to 8. X plus 6 is equal to, how many z plus 8? 5z plus 8. So x is 5z plus 2. Right? Yeah? Now, when we write the coordinate point, what is x? 5z plus 2, comma. What is y? 3 minus 3z, comma. What is z? That's just z. You always put z for that
So
one.
you still have to solve even if it's infinitely many.
Right.
To do that.
You still have to do that. Now this now lays out, it maps out. Remember how we said it's infinitely many solutions, not necessarily all reals?
Yeah.
With this now, you can generate all of those infinite solutions. So you say to yourself, okay, what if x was 0? Then we get 2, 3, 0. What if x was 1? What if x was negative 2? You know, and so you can get like a whole, you know, plane or whatever. Okay? Isn't that cool?
Yeah.
Okay. All right. So next one. Okay, go ahead and put this in row echelon form. Not first, let's put it in matrix form. Okay, so go ahead and do that. Yes, R1 minus 2R2. R1 minus 2R2. 0, 1. What do we get? R1. 3. 1 minus 10, negative 9. And then this one just comes over. Okay?
Yeah.
Now, next, I want to get rid of this one. So, what are we going to get? So we see, we have 2, 3, minus 1, 1, 0, 1, 3, negative 9. You can just add, right? Row 1 plus, no, row 2 plus row 3. 0, 0, 0. Ooh, plot twist, negative 12. What about that?
I don't know.
No solution. Right? What does that tell you? 0z is equal to negative 12. When is 0 equal to negative 12?
Never.
Never. So that's no solution. Okay? So that's how we get no solution. Okay. We're good?
Yeah.
Now, let me tell you something else. Suppose you're at the second to the last step here and you want to get rid of that negative 1, right? The reason why I do them in this order, right? Bottom left, 1 above, 1 to the right, is so in the end, I have 2 rows with zeros in the beginning and I only have like 2 things to play with here, so it's a lot simpler. Students sometimes though, they're like, oh, the negative, okay, so I can combine this negative 1 with the 3 on top, right? Let's say it was like, you know, easy to do. But when you combine this last row, row 3, with row 1 at this step, what happens to that first element over there?
It's not 0 anymore.
It's not 0 anymore, right? So when I add this one to this one, when I combine those two to get rid of that highlighted -1, what am I going to do? So suppose I'm going to multiply row 3 by 3 and add it, right? So here I get 0 plus 2. Well, now I have reintroduced a 0, so I kind of like undid what I was supposed to do, right? You would get another 0 at the bottom left. So that's why at the very end, I just like to combine the bottom two rows. Okay? So once you've got zeros here and here, just stick to those two rows. Okay? All right. Let's see. Let's do this one. What do you think? Let's see. So what do you guys think? Let's take a poll. You think it's going to be no solution, infinite solutions, or one solution? What do you think? Who thinks one solution?
Are you able to just tell by the...
No?
So we're
I'm just guessing. It's fun. We're voting. Who says infinitely many? Who says 0?
Give me the 0.
Let's see. Let's do it. Okay. 1 minus 1, 1, 3. Okay. Such fun. Right? Okay, so first. All right, so I want to get rid of the bottom left. So this one. What are we going to do? Works for me. Okay, so 2 minus 2 is 0. -2 minus -3 is 1. 2 minus 3 is -1. And then -2. Yes? So we're doing 2 row 1 minus row 3. Okay. Next, I want to get rid of this one. What do you guys think? What should we do? Row 1 plus row 2. 0, 1, 0. Ooh, 5. Next, 1 minus 1, 1, 3. Okay, now we stop. Okay, okay. When we do this, right, the point is to get a row where you only have one, right? Or like where you only have one element, right? So this one, okay, you could already stop. If it doesn't ask you to put it in row echelon form, you could actually stop here and solve this matrix, right? Because the second row, now everything got eliminated and you just have y equals 5. So you've already pretty much solved it, right? So from row 2, we can say y is equal to 5.
But are there times when you're going to want us to like not do that and just keep going?
Yeah, and I'll show you how to do that if you need to. So y equals 5, and then from the last row, I can say y minus z is equal to -2. So z is equal to 7. Okay? And then from the top row, what do I have?
Oh.
X minus 5 plus 7 is equal to 3. X is 1. So I get 1, 5, 7.
That's what I thought, but then no.
So, yeah, I brought the z over and took the 2 over. Okay? All right. So